Good morning everyone. Children, today we are going to take a new chapter which is application of derivatives. This chapter has a weightage of 6 marks in your board examination, and in 2020 also one question of 6 marker had hit the paper. So this chapter can make you rich by 6 marks if you prepare it well. So let's see its first topic, which is rate of change of quantities. Children, whenever we are talking about rate of change of quantities, that means we will be comparing two quantities, like what effect one value gives on the another value. Children, in chain rule you have read previously that if you wanted to calculate dy by dx, or I can say if two variables are linked up with the third variable, then it's like this. If x equal to say sine theta and y equal to cos theta, that means two variables are linked up with another variable, then by chain rule we have calculated dy by dx, which is again I can say change in the value of y with respect to x. So we did it like this: dx by d theta equals cos theta, and then dy by d theta is equal to minus sine theta. And now we wanted to get a relation between y and x. We wanted to compare y and x variable. So by chain rule we have tried it like this: dy by dx gives you d by d theta by dx by d theta. So it is giving you dy by dx, d theta gone. So it is giving you this thing. That means minus sine theta by cos theta, which is equal to minus tan theta. So this is just the comparison, or this is the change in the value of y with respect to x. Children, say if I want to find out change in the area of the circle if radius is increased or decreased. So if you want to find out change in the area with respect to r, then you will be denoting it like this. That means you are differentiating a with respect to r. That means what is the rate of change in area with respect to r. Say if I take a distance, say x is your distance, then if I write it like this, that means what is the change in the value of the distance with respect to time. So this is how we denote rate of change of quantity, and simply I can say rate of change of quantity can be denoted by, if I am taking it with respect to time, then it will be d by dt. Now whatever is the function you will be writing here. If you are taking it with some other value, you will be writing that value here. That means d by dt shows the change in the value with respect to time. Now let's see how we can apply rate of change of quantities in the given questions. Look, in this question what we can do. It is given the volume of a cube is increasing at the rate of, this is the rate of change in the volume. So this is rate of change, so I will be writing change in volume with respect to t. Why I have written with t? Because here the unit is per second. So change in volume with respect to time is given to me as 8 centimeter cube per second. How fast is the surface area increasing? How fast is the surface area increasing means you need to find out change in the surface area with respect to time. This you need to find out. When the length of an edge is 12 centimeters, say we take edge as A. Let edge of a cube be A centimeters. Then when A equal to 12 centimeter, then what will be the change in the surface area? Let's see what we can do here. We know volume of cube is equal to A cube. I can differentiate, since I am given with dv by dt, so I will be differentiating it. dv by dt equal to 3a square into, but this a is again differentiated with t, so this will be dA by dt. Now the value of dv by dt is given to me. This is 8 equal to 3a square into dA by dt. This can be written as dA by dt equal to 8 by 3 a square. Now children, I need to calculate rate of change in surface area. So I know again surface area of a cube is equal to 6a square. So if I want to find out change in surface area with respect to time, that means I will be differentiating it with respect to time. This will give me 12a, but then a has to be again differentiated with respect to time. Now dA by dt, I know from here it is 8 by 3a square. So this is ds by dt equal to 12a into 8 by 3a square. Now a and 1a is gone, 3 ones are 3 fours are. So ds by dt, when your a is 12, so you will be writing it like this: change in surface area with respect to time when edge is 12. So it will be 4 into 8 by a. And what is your a? It is 12. So 4 into 3. So this is 8 by 3. So this is just 8 by 3. What about unit? Since you are taking here surface area, so surface area will be in centimeter square and t is taken in second. So 8 by 3 centimeter square per second is your change in surface area with respect to time when your edge is 12. Look at this question, children. It is given a stone is dropped into a quiet lake and waves moves in circles at the speed of 5 centimeter per second. When a stone is dropped in a quiet lake, then the circles, that means the ripples so formed, will make the circles. And it is given that at the speed of 5 centimeter per second. What is this? This is change in the radius. A stone is dropped into a quiet lake and waves moves in circles at the speed of 5 centimeter per second. That means this is the change in the radius of the ripples. So here it is given dr by dt. Why I have written dt? Because time is given here, second. So this is given as 5 centimeter per second. At the instant when the radius of the circular wave is 8 centimeter, that means when your circle is of 8 centimeter, then how fast is the enclosed area increasing? That means you need to find out change in area with respect to time when r equal to 8. Okay, so here dA by dt is to be calculated. So I know A equal to area of the circle equal to pi r square, and dA by dr can be calculated as, I am differentiating it with respect to say r. If I am taking time, then I will be differentiating it with respect to time. So this is dA by dt pi into 2r into radius is again differentiated with respect to time. Now this dr by dt is given to me, so I will be writing it as 2r into 5. This is my dA by dt. Now I want to calculate dA by dt at r equal to 8. So I will be just putting the value of r here. So it will be pi into 2 into 8 into 5. So this is 80 pi. Now since this is change in area with respect to time, so your unit will be centimeter square per second. Children, unit is of importance here, so you need to put it very carefully. Let's see another question. In this question it is given that a ladder 5 meter long is leaning against a wall. So say this is your ground, this is your wall, and this is the ladder which is leaning on the wall, and its length is 5 meters. Say this is your x unit, and say this is your y unit. So from here, if it is a right angle triangle, then we can say that, say this is AOB. So in triangle AOB, I can say x square plus y square equal to 5 square, that is 25. I have applied Pythagoras theorem here. This square plus this square equal to this square. So this is my equation. Now what next is given to me? Leaning wall. The bottom of the ladder is pulled. That means from here the ladder is pulled against the wall, away from the wall. This is your wall here, and if I am taking and moving it away from the wall, then obviously this will go somewhere down. Okay, so if you are pulling it down, that means it will come down away from the wall at the rate of 2 centimeter per second. What is this? What is this? This is the change, but change in what? This is the change in your x distance. That means you are given with dx by dt, which is 2 centimeter per second. How fast is its height on the wall? This is your wall. How fast is its height on the wall decreasing when the foot of ladder is 4 meter away from the wall? When this foot is 4 meter away from the wall, then by how much this length has decreased? Okay, so I'll be calculating it. That means I need to calculate my change in y with respect to time at when x equal to 4. When x equal to 4, that means when your length on x-axis is 4. So let's see, I can differentiate it here. 2x into dx by, since I am doing all the work with respect to time, I am finding out change with respect to time. So dx by dt plus 2y into dy by dt, and this is a constant, so it will become a 0. I can take 2 common and I can send it that side, so I will be just getting dx by dt plus 2y dy by dt equal to, not 2, it is just y dy by dt. Now children, it is given when x equal to 4. This is my equation 1. So when x equal to 4, that means from 1, if x equal to 4, then what will be your y? Your y will be 16 plus y square equal to 25. That means y square equal to 25 minus 16, y square equal to 9, and y equal to 3. So I have got my value of y as 3. Now I will be putting this value in my equation. Say this is my equation 2. But children, you need to see here, this is 4 meters whereas this is centimeters. So I will be changing into meters. So if I change into meters, I will be dividing it by 100. So x is over here 4, dx by dt is given to me 2, but if I change into meters, so I will be dividing it by 100, plus y is 3, and dy by dt you need to calculate. So I will be getting it as 250. So here it will be 3 dy by dt equal to minus 4 by 50, or I can say dy by dt equal to minus 4 by 150. Now this is what? This is meter per second. What this minus sign indicates? This minus sign indicates that the length of your y unit is decreasing. If it comes out to be positive, that means it is increasing. If it comes out to be negative, that means it is decreasing. Or here I can further simplify it. 2 2s are 4. So I can write it as minus 2 by 75 meter per second. And if you want to convert into centimeter, then you can multiply it by 100 and you can calculate it. Have a look.